So in the DSC syllabus, there are several common oxidizing agent and reducing agent. You have to memorize their formula and the corresponding products form. Say for example, for permanganate is one of the strongest oxidizing agent in your syllabus, and in acetic medium, this product is Mn2+. And if you ask me, do we need to really memorize that MnO4 is an oxidizing agent? The answer is no. As long as you can memorize the original reagent and the product, you can check their oxidation number to identify whether they are OA or RA. Say for example, for permanganate, for MnO4-, the oxidation number of Mn is +7, and then after the reaction in the product, Mn has an oxidation number of +2, and you can see that there is a reduction of oxidation number. There is a decrease in oxidation number, so that it should be a reduction. And what's the meaning of reduction is that it gains electron in the process. Then how about its reaction partner? For MnO4-, it has to gain electron. It means that its reaction partner it has to lose electron. And if its reaction partner lose electron, then it should undergo oxidation. So for MnO4-, it actually forcing its reaction partner to lose electron, so that it make the other species to undergo oxidation, so that it should be an oxidizing agent. And something more is that for permanganate, you can easily link this name with its formula, because for manganate, this part, it actually comes from the element's name, manganese, and this symbol it should be Mn. So permanganate it should consist of Mn as one of the atoms, and then for the species with ATE inside, it means that it should contain some oxygen atom. So for permanganate, its ion it should contain Mn, and of course it should contain oxygen. So the combination here is that 1 Mn with 4 oxygen with a minus charge. Or if you still do not understand, then just try another example. It's called dichromate. And again, we split this ion into parts. For chrome, it comes from the elemental name chromium, and chromium should refer to the Cr part here. And then for the prefix di, it means that it consists of 2 chromium. And again, the suffix ate means that it consists of some oxygen. So in this dichromate ion, it has 2 chromium and then some oxygen inside, and its formula is Cr2O72-. And what you have to do is again to memorize the product form. In this case, you should form chromium 3 ion. And again, if you check the oxidation number for dichromate Cr inside, it has an oxidation number of +6, and then in this product, its oxidation number is +3, and you can see that for each of this chromium atom, there is a decrease in oxidation number, there is a reduction in oxidation number. So it means that it undergo reduction, and in the process, it gains electron. And then what happened to its reaction partner? Of course, its reaction partner have to lose electron, then its reaction partner undergo oxidation instead. So dichromate, it forces its reaction partner to undergo oxidation, so that it is said to be an oxidant or oxidizing agent. And similarly for the rest of these species, for the halogens, they will form their corresponding halide ion. And for H2SO4, be reminded that only its concentrated state we use liquid to represent the idea. It's because in concentrated sulfur acid, it consists of H2SO4 of 98% by mass. So that the same symbol we use liquid here, only 2% is water. in its corresponding product after reaction is SO2. And originally in H2SO4 it has a plastic oxidation stage for sulfur, and after it's plus 4. And again it gains electron and it forces reaction partner to lose electron. And for nitric acid it is somehow complicated because you have to identify if it is diluted case or concentrated case, and the product are NO and NO2 respectively. And for what rest of the species, for Fe3 plus iron 3 ion, it will reduce back to Fe2 plus if it acts as an oxidizing agent. And then for some ion come from some unreactive metal, they are willing to accept back their electron to become its elemental state again. So Ag plus is also one of the strong oxidizing agent. And then for the reducing agent part, most reactive metal they are reducing agent. Let's say for potassium or lithium, they're willing to lose electron and then to become K plus or lithium ion by losing one electron. This electron, it cannot naturally exist alone. It will be immediately absorbed by some species, immediately gained by some species. It means that its reaction partner will gain electron and undergo reduction. And then for the metal itself, because it's forcing its reaction partner to reduce, so that they are said to be a reducing agent. And for halide ion, they will form back their halogens by losing one electron. And one of the commonly used reducing agent is sulfide ion, sulfide, and with ITE. And then its product is SO42 minus called sulfate ion. And in case you do not memorize that, the difference between ITE and ATE is that, okay, for the ions, anion, and with ATE, it should consist of oxygen and it should contain more oxygen. And then for the one with ITE and with ITE, it should have one oxygen less. So for sulfate ion, is SO4 2 minus, and for sulfide ion, it consists of one oxygen less. So it is SO3 2 minus. Oh, and finally, is Fe2 plus. If it loses electron, it will become Fe3 plus. If you really perform the reaction for Fe2 plus, and then it will turn from pale green into yellow brown in color. And again, in the process, it will lose one electron, and this electron will immediately absorbed by its reaction partner. So its reaction partner for iron 2 ion it undergo reduction, so that Fe2 plus is said to be a reducing agent in this case.